Okay, so guys, this sheet it will be checked on Monday. I don't see you tomorrow, okay? Because I'm proctoring the test. Those of you who are not taking the test should be reporting to the gym, and make sure that you go up and check attendance or because I'm proctoring. Oh yeah, I will see you. I'm sorry. Yeah, I will see you tomorrow. Yeah. And then I'm proctoring on Thursday as well. Okay, so guys, um, the key to this check is knowing your parts to the circle. So you might need to refer to your doodle notes. Guys, stop talking. Um, the white sheet will be homework. I am going to stamp the front page, and then I'm also going to talk about what you have to turn in before you leave. So this is just, can you name, identify the part in relation to the diagram to the right. So I'm hoping you recognize B. B is actually the point of tangency. That is G. That was part of our level 1 notes. BH, this is one that we haven't really talked about. BH is a common tangent. Yeah, it's a tangent in both circles, C and G. It's a tangent to both. AB, the segment AB is what? Yeah, it's a chord, so that would be C. Now it says the line AB. Secant. Secant. You need to know these by heart because we're going to go into the special segments relationship. And if you can't identify it, you're not going to be able to apply the correct rule. All right, so um, line AE, that's a tangent. G, that means point G. Yep, that's the center. And then segment CD, yep, that's your radius. And then segment BD, that was your diameter, okay? All right, so this first section, 1 through 23, okay, there's not a lot of review we're going to do on this because this was part of the 11-1 that we did at the beginning of the circle unit. So I want you to see if you can, some of it does not require any actual computation, any work, because you're just applying the theorem. So number 9, they want us to find OP. Okay. How do we find the length of OP? Yeah, this is a radius. This is a radius 17. Done. Guys, we should know that by heart. Two tangents are congruent, or we can think of cone head. All right, S is 8. 11. What's the relationship? We should be, this is a tangent, so we could do Pythagorean theorem to find it. Okay. The answer is 9. Yeah, it's, yeah. All right. 12, SR would be, so OT would be, yeah, they're tangents in a radius. On 13, OC, O to C, that is 6. So what would I do to find AB?
6 and 10.
What is AB?
It's going to be 8. No, it's 8 because that's a triple. So it's 8 and 10.
I'm just asking what segment is AB?
Oh,
It's a tangent. And what's the tangent relationship?
it's the long leg of the right triangle.
No,
The last answer. Because you were answering the wrong question.
it's perpendicular. You have to make it, it's perpendicular at the point of tangency to a radius. So now that represents the C, the hypotenuse.
It's 6 squared.
I'm not saying it's not, Ben. I'm not saying it's not. All right, and then 14. What do we use on 14? Yeah. 8. Because this is 10. Use Conehead again. So AB would be what? It would also be 5. ED, yep, 7. BC would be 8. Yes, you did. Okay, so guys, this is the part you have to add to complete the homework. This is the gold or orange paper you picked up when you walked in. Okay, so to find lengths of segments related to a circle, you have to be able to recognize a secant, a chord, and a tangent because they all have different relationships or rules. All right, so the first example here is secant, secant. Okay. If you have two secants, from the same external point, then the product length of one secant and its external part is equal to the product length of another secant and its external part. Okay? Another way we think of, if I see secant, secant, you got to know the parts to the secant. And another way I like to think of using the secant, secant is think of the ow, ow. Okay? So, to a secant, guys, to the secant has, oops, I don't need that. The secant has an outside part, that's the O, or the external secant, and it has the whole part. The whole is your secant. Okay, so you compare the outside and you multiply it to the whole secant. This happens for both secants. You need to have two secants to do that. And another thing, please do not just think a secant is a line that goes through. A secant that enters is a segment or a line that intersects a segment at 2 points only, exactly 2 points. So on the second secant, you have an external part. You have the whole secant, but then you also have the outside part. So for secant, secant, you always take whatever's on the outside and you multiply it to the whole, whole secant. That product is going to equal to the other outside times the whole secant. I'm going to move this over. Alright, so it's outside times the whole secant is equal to the outside times the whole of the second secant. The key to this is knowing to do that relationship whenever you see two secants. Now, if you see a tangent and a secant, well, your tangent part only touches the circle at exactly 1 point. So you gotta make sure you pick the right segment that represents the tangent. So we have a tangent secant. Again, when I'm talking about the secant, I need to recognize the outside part compared to the whole secant. So whenever you have a tangent secant, the tangent part, when you square it, is equal to the outside part times the whole secant. Okay, the tangent squared is equal to the outside part of the secant times the whole secant. And then the last relationship you have with segment lengths is chord, chord. if you have two chords that intersect, okay, two chords that intersect, then the products of the lengths of the segments of one chord equals the product of the segment of the other chord. So if I'm looking at my green chord that I highlighted, what are the parts to that green chord? P and Q. So P times Q is going to equal to the parts to my yellow chord, which would be the product of those parts, which would be R times S. All right, so if you look at the example we have, I need the product of the parts to one chord. And it's going to equal to the product of the parts to the other chord. I need a chord. Do you see a chord?
Yes.
Give me the parts.
Plus 4 times x equals x plus 1 times c.
4 times x, those are the parts to one chord, is equal to the product of the other two. So 4x basically equals
3x plus 3. So x has to be.
Yeah. So, yes, when you subtract the 3x, x equals 3. All right, so mixed practice. Number 1. First, let's see what you can label the parts, the segments, the special segments to the circle. Okay, this segment X represents what type of segment? So write tan there, that's the tangent. Okay, what other special segment do you see?
Select time travel.
A secant. Who would be the secant?
4 and 5. 4.
It's 4, y, and 5. All of this.
The future what would already be dead.
All of that would be a secant. All right, and then in the interior, we have chords. You need to start with the y because the y is part of the chord. Although it's also part of the secant, we can do chord to solve for y. So using chord, I can find the y. So what product parts do we have? 8 times 5 equals 4 times y, which is 4y. So what is y going to end up being? Yeah. Okay, so now that we have that, we can plug that in for our y, which will help me with my secant. Okay, because that y was part of the secant. All right, how are we going to get to the x? What are we going to have to use for the x? Yeah, we're going to do tan secant. So we take the tangent, we square it. It's going to equal to the outside times the whole of the secant. The tangent is the x, so that's x squared. What is the outside part of the secant? And the whole length of the secant. 19. We add it all up. 4, 10, and 5. 19. So we get x squared equals 95. And then you take the square root. So x equals the square root of 95. Okay, 2. Start off with labeling all the given information. Start off with labeling all the given. So LM is 7, MN is 8, TN is 10. This is not to scale. PR is 3, RM is 6, and LT, which is the whole segment here, is 11. They want us to find PT and LR. Starting out with PT, I'm going to put an X there. I'm going to use a different variable for LR though, guys, so I don't get mixed up. Okay, so you got to determine which parts could you use to find PT. Which rule? Do I have a tangent?
No.
No, I don't have a tangent. Yeah, secant. Secant. Where's one of the secants?
LS.
Yeah, this is ln is the secant. Where's the other secant? Yes, pn. Alright, so whenever you do secant, you do outside times the whole equals outside times the whole to each secant. So for secant ln, that would be 8 times 15, right? And then to do the secant pn, that would be 10 times x plus 10, because you have to add up the parts to get the whole secant. So we have 120 equals 10x plus 100. Now we're solving for x. Yes. You should have x equals 2. Okay, now to find LR, LR is going to be my y. That is this part of a chord. Which chord could I use? LT. Okay, so to do chord, you need two parts to two chords that intersect each other. Well, LT intersects PM. LR, excuse me, here is Y. So what would this little piece here that remains be? Because we got to do part times part. 11 minus Y will give me the remaining part. Because we know the whole chord is 11. That's going to equal to the product of the parts of an intersecting chord, which would be, yeah, PM. So we can do 3 times 6. Multiply those parts. This turns into a quadratic. Because when you distribute, you get 11y minus y squared equals 18. To solve it, we want the leading term to be positive. So I'm going to move all of these over to the right. So y squared minus 11y plus 18 equals 0. Now I can factor. So we want factors of what? Of 18 that have a sum of a negative 11. So negative 9 and a negative 2. So y equals 9 and positive 2. So that means LR would be the 9 part, right? And then the RT would be the 2. Okay? Alright, so after you need to use, guys, you need to use this for the last section of the white sheet you picked up. Segment lengths in a circle. Okay? So make sure you stay on this side of your notes to help you on the last section.
Do we need to do this?
No, we're doing the other side tomorrow. Okay? Alright, so name each segment. Where's the tangent? Yes, this is it. Name the tangent. ST. Name 4 segments of chords. GL, NL, LK, and LP. Those are all parts to a chord. A secant segment. Yep, SP. An external secant segment. Yep, SG. The key to the remaining problems is recognizing the special segment that is part of the circle and the relation that goes with it. So, number 5. What rule can we use on 5? Yep, chord. Because you have two chords intersecting. So basically 9x equals 3 times 12, which is 36. Alright, on 6, what rule, what relationship? Tan secant. Okay, so tangent secant is you take the tangent and you square it, and that's going to equal to the outside times the whole secant. So basically we have x squared equals 5 times 20. When you take the square root, x is equal to plus or negative 10. Plus or negative 10. 7. What's the rule for 7? Yeah, secant. So outside times whole equals outside times whole. So 3 times 8 equals 4 times x. What is x? Huh. 4 is the outside part. X is the whole secant.
I'm pretty sure 3 squared has an x. 3 squared.
Okay, number 8. 8 is also tan secant. Tangent secant. What's the rule for this?
Tangent squared.
Yeah, tangent squared equals out. Okay, so what part is the tangent? So we take the 12, square it. What's the outside part? X times the whole secant, which is 18. So we got 144 equals 18x. Okay, 9. What's 9 going to be? Chord. So we would have 9x equals 45, because 3 times 15.
Oh, it's.
Yeah. All right, guys. I just want you to make sure you read this correctly. The 8, guys, this is the 8. The chord part is your 8 here. And then the x is the chord or the internal part of the secant. Okay? This should be secant, or you can think of it as ow. So outside times the whole equals outside times the whole. What's the outside part of one secant? So that 4 gets multiplied to the whole secant, which is 12. And then the outside part of the other secant is 3. 3 plus x, yes. Do we have questions on what we're doing here? This worksheet we're going to check tomorrow.